Hey, what's up everyone? I'm Damien. You can find me around on Nostr as Good Enough, and I'm doing a workshop today on Nostr Wallet Connect, otherwise known as NWC. Here for this workshop, we have the link to the slides at tinyurl.com/plebdevs-nwc. Here's a link to our GitHub and a link to our website. So getting right into it, we're going to be using Nostr for Nostr Wallet Connect. So before we start talking about what Nostr Wallet Connect is, let's touch briefly on Nostr. Nostr stands for Notes and Other Stuff Transmitted by Relays. Nostr has clients that construct and broadcast events, and relays that store and stream events. The communication between clients and relays happens over WebSockets using filters and subscriptions. So clients will construct what are called filters and create a subscription to the relays and say, hey relay, I want events that match this filter. And best of all, Nostr is an open protocol with a simple event format, so you can pretty much build anything you want, even if it's not officially in the spec. Speaking of the spec, here we got NIP01, so we can go check this out real quick. NIP01 is where the basic protocol flow is described. We have events and signatures, so you can read through all this and kind of start to dig in more on how Nostr exactly works. But you can see events have tags, so here is what a Nostr event will look like, and Nostr events have tags, and these can be any number of things. An important thing to note is that a lowercase single character will be indexed by relays, so you can filter by tags that have a single character. Events have kinds, so kinds specify how clients should interpret the meaning of each event, which just means all events look like this, but because they can have different kinds, the clients can start to show them in different ways depending on what their kind is. What else do we have? We have communication between clients and relays. This is what I was describing with the WebSocket communications. We're going to be using NDK, which handles all this. You don't really have to worry about it. But you can see down here that these are what filters look like. You can send anything within here to relays, and they'll respond with events that match that filter. So you can filter by specific event IDs or by authors of certain events, etc. And that's pretty much it. There's more you can dig into. There's a whole list of NIPs here. NIP01 is mandatory. So what is Nostr Wallet Connect? Nostr Wallet Connect is a protocol. And by protocol, I just mean a set of rules that two pieces of software can follow. And by following those rules, they are able to communicate with each other. In the case of Nostr Wallet Connect, it facilitates the communication between your Lightning wallet and your apps. This is just a high-level picture of what it looks like. On the left here, we have your Lightning wallets. So it could be on a desktop, it could be on a phone, and through Nostr Wallet Connect, you're able to connect to other apps. This comes from nwc.dev, which has some good documentation. You can read how it works. There's links to some SDKs, and this is a good place to dig more into Nostr Wallet Connect. So with Nostr Wallet Connect, what are we trying to solve? We want to allow apps to interface with your wallet. We want these apps to be able to pay, receive, and show transaction data. So maybe the app wants to show a list of past transactions that have completed and failed. Nostr Wallet Connect is not just for Nostr. So what I mean by that is the social media apps that you'll see on Nostr, those are kind of a primary use case for Nostr Wallet Connect, because by connecting your wallet to your Nostr client that you use like Twitter, you can enable one-click zaps. But we're just using Nostr as the communication layer for the communication between our wallet and our apps. So With that, we get some privacy benefits. We get the option to have asynchronous payments because payment requests can be sitting on relays, and it's relatively simple for apps and wallets to implement. This is kind of what the protocol flow looks like. We'll go deeper into the exact interactions between these entities, but here we have an app and a wallet. These are both Nostr clients, and then this is a Nostr relay. So the app will send an event to the relay and say, hey, pay this invoice. The event can just be sitting on the relay here, and then the wallet will come online and ask if there's any invoices to pay and pull that event to the wallet. Then once the wallet pays it, it'll send an event back to the relay saying, hey, look, I paid this. And finally, the app can see that and confirm to its user that the payment has completed. With this, you should be able to enable payments pretty much everywhere. You could do sort of e-commerce, gaming, social tipping. That's the example of Zaps and using it in the social media apps. Patreon or course-like platforms. So maybe you want to consume content one at a time, and you don't necessarily want to load a balance onto the app. You just want to authorize the app to spend some of your money when you consume this content. Or just subscriptions in general. You could do a 1 week or a 1 month subscription, and it would pull the amount that subscription costs from your wallet. Here's another example of a Discord bot that I made using Nostr Wallet Connect. So with it, you're able to type one command and zap 56 people in this example. And these are each individual payments coming directly from my wallet. So what makes Nostr Wallet Connect special? We have other solutions that try to do something similar. The main one is LNURL. But with Nostr Wallet Connect, we get individual connections. So each connection can have a budget and an expiry. It benefits from Nostr's privacy because each connection gets its unique key pair. And so the app and the wallet don't really know who each other are. They just know that they're communicating over Nostr. And each of these connections is revocable. So you can connect to an app, and you don't have to trust that that app will delete your connection later. You can go into your wallet and directly revoke it. Nostr Wallet Connect, I think, is the best way to connect your wallet to apps. So if you're trying to build an app that you want your users to be able to send and receive payments, Nostr Wallet Connect, I think, is the way that you should do that. So getting more into how Nostr Wallet Connect works. We have apps. Those are Nostr clients again. These apps send requests and receive responses. And then there's wallets that receive the requests and send the responses. Nostr Wallet Connect is in NIP 47, and it defines 3 new event kinds. Today we're going to talk about requests and responses. So requests are of kind 23194, and responses are 23195. Going deeper into that example of the protocol flow, using what we now know about requests and responses, we can see we have an app, say Amazon, because Amazon is a place where you'll create an account and you'll come back over and over and over, and you'll want to just be able to click checkout, buy whatever you want, and not have to worry about scanning invoices or anything like that. And then we're going to use Albi because they're one of the 2 wallets. Mutiny is the other one that supports Nostr Wallet Connect. So the first thing that we need to do is create a new connection. So we have these 2 apps that we are logged into, but they don't really know about each other. They can't communicate. So in order to start using Nostr Wallet Connect, we need to connect them. In order to connect them, we'll need a connection URI. This has a couple different pieces. It has the protocol, the wallet's public key, the relay that the wallet and the app have decided to communicate over, and a secret, which is essentially the private key for this connection. So you can see in here we kind of have 2 key pairs. We have the wallet's public key shown in green, and we have this connection's private key shown in pink there. A full URI will look something like this, where we have Nostr plus Wallet Connect as the protocol. You can see an example of the wallet's public key. So as the app, we don't know the wallet's public key, but we don't know the wallet's private key, but we do know their public key, and this is going to be important for having encrypted communications, which we'll get into in a minute. And we also have our private key for this connection, and the wallet will have the public key of this connection. So the question becomes, how do you get a URI? There's a couple options. You could scan a QR code, you could copy and paste it, which we'll go through that flow in a second, or there's Nostr wallet auth. So this is how Alby handles it. You can go to nwc.getalby.com if you have an Alby account, and this is kind of their interface as a wallet for creating a new Nostr wallet connection. So you have the app name that you're connecting to, you have the budget of how much you want this app to be able to spend at most from your wallet, and the option to add an expiry as well. And you can kind of see here, there's a whole list of things that you're authorizing the app to do. In this case, we're giving it complete permission to do everything, but maybe we only want it to create invoices, for example. So you can configure that here. And then Alby shows here the option to copy it or scan a QR code. So at this point, you will have a connection URI, and you can paste that into your app. Or there is Nostr wallet auth, which is defined in NIP 67. It's still not officially part of the main NIPS repo. You can see here it's in Ben the Carmen's fork of the NIPS. Hopefully that gets merged in soon, but for now we can just go off of this. We can check this out real quick. So again, we have an app and we have a wallet, and the goal is to get one of these connection URIs. So what we need is to, this is a Nostr wallet auth URI. This is not a Nostr wallet connect URI. So what we want is to construct this and be able to create a link that our user can click, and it will open up the wallet. And so this Nostr wallet auth URI will have some information like a relay. This secret is used just for the communication between the app and the wallet. It's not actually the private key of the URI, so that the app will construct on its own. And what happens is the user will deep link into the wallet. So they'll have a link with that Nostr wallet auth URI, and they'll click it, the wallet will pop up and say, hey, do you want to confirm this connection to XYZ app? And with this, the wallet will send a kind 33194 event back, and from that, the app and the wallet can collaboratively construct the connection, where each, the wallet and the app, generate their secrets separately, so that the wallet and the app can kind of do whatever they want in terms of key management, but there's no copy and pasting of private keys. And this is what is in the content of this kind 33194 event. Most notably, it has commands. So those are the commands that the wallet supports. This is just a quick run through of Nostr wallet auth. We're not going to use it today in today's workshop. Maybe we'll do another workshop later on it, but definitely something worth digging into if you want to make a seamless connection for your users. So however we get a URI, we need to get it into our Amazon app. So shown in purple here is kind of that we're the same entity. We have Alby and Amazon are both the same entity. Maybe I'm logged in to both of them. And we just take the Nostr Wallet Connect that we get from Alby and we put it into Amazon, and now they're connected. So now they can communicate over Nostr. Nostr is a relatively public network. You could have private relays, but for the most part it's pretty public. So how do you have private communication on a public network? Well, that's where NIP04 comes in. So NIP04 is used in this case to encrypt event content. For NIP04, we need to do a Diffie-Hellman key exchange to compute a shared key. So remember, we had in our connection URI, we had the wallet's public key and our private key. So with that information, we can compute this shared key. This shared key is a new private key that is the result of combining one public key with another private key. And the cool thing about it is that as an app, I can use my private key and the wallet's public key, to compute the same shared key that the wallet could compute with the app's public key and the wallet's own private key. So this is a little weird to wrap your head around. The question for me is usually, what keys do I use? Well, just think about it. No matter what entity you are, only you should have the private key. So think, I'm going to use my private key and your public key, and the other person, the entity on the other end of this communication, is going to use their private key and my public key. And then it's encrypted using this method, and we end up with this encrypted content in base 64, and this is the initialization vector just comes from the encryption scheme. So there's a library called Nostr tools that you can use that implements NIP04. So if you're using JavaScript, you don't really have to know any of this. You can just use these encrypt and decrypt methods, as long as you know which keys to use. That's the most important part. You want to make sure that you're using the right keys so that you're encrypting to the correct shared key. All right, so now our app and our wallet are connected. We now want to pay this invoice. So we're going to send a request. Remember, apps send requests, which are of kind 23194, and that's going to have that invoice in it. It's going to drop it on the relay. What does this request look like? It looks something like this. So this is familiar. This is the Nostr event format. It's going to have this kind 23194. The content here looks like a bunch of gibberish. It's encrypted. So remember, we use NIP04 to decrypt it, and this is sort of an outline of what the decrypted content will look like. It'll have a method and params. We'll get more into those in a minute. And finally, it has tags. So requests have a P tag with the wallet's public key. So in order for wallets to properly be able to listen for requests to them, because this content's encrypted, they don't really know about it, so they need to be able to filter for events of kind 23194 tagged with their wallet pub key. And then these are just extra things, like this is the time that the event was created at. This is when you hash all of the event content, you get the ID, and the signer of the event, this is their pub key, and then once you sign it, you'll sign this ID and you will get a signature. So more on the methods that can go. Remember, we have in this decrypted content, we have this method field. So there's a bunch of methods that you can put in here, and you can pretty much build a fully functioning app using Lightning. So there's pay invoice, which accepts an invoice as a parameter. There's make invoice, which takes an amount and a description as parameters. You can look up invoices by their payment hash or by the invoice itself. And you can list transactions, and it takes a set of filters here. So you could say, I only want transactions from 10 minutes ago, for example. And there's a bunch of other ones. Most interesting, there's these multi-pay invoice and multi-pay key send. So with these, you're able to send one request and pay multiple invoices. All right, so now the wallet picks up this request, and it decrypts it. It looks at it. It's like, all right, this is good. I'm going to pay this invoice. Now we get a pre-image back from wherever that invoice came from, and the wallet can now send a response, because ultimately this app wants to show their user that the payment was completed. So the wallet will broadcast a kind 23195 response, and those look something like this. Again, very similar, but we have a kind 23195 event instead, signifying that it's a Nostr Wallet Connect response. We again have encrypted content that, when decrypted, looks a little bit different. It's got the result type, so those take the same options as the method field. The result data itself, or an error code. So if the execution of the request fails for some reason, there will be an error code, and if it's successful, there will be a response. And finally, responses also have tags for a similar reason. The app needs to be able to listen for these responses. So it'll be tagged with the app's public key, and it will also be tagged with the request event's ID. So this is important so that the app can tie responses to specific requests that it sent. These are the error codes that are defined in NIP47. They each have their own description you can go look at in the NIP itself. Most notably, we have unauthorized. So this is saying that the app is trying to make a request to the wallet that it doesn't have permission to do. So maybe you connected to the app and later you revoked the connection in your wallet. So then when the app tries to spend on your behalf, the wallet will say you're unauthorized to do so. All right, so finally, this response gets picked up by the app, and you can see that the invoice is paid, and you can show that to the user. In the case of paying an invoice, it should have a pre-image, which the app can validate with the invoice that they're trying to pay, but it's also just a response from your wallet itself saying that the wallet paid the invoice. All right, so getting into the coding portion of this, we're going to be using WebLN and the Albi extension to build a Nostr Wallet Connect wallet. So this wallet is mostly just for learning purposes. I don't expect a wallet that implements Nostr Wallet Connect to really be built this way, but I think it's a simple way to illustrate how wallets can implement Nostr Wallet Connect, and from that you can start to build apps too. I think that most of you will want to be building apps that use Nostr Wallet Connect, but it's important to understand the other side of the equation here. So today we're going to be building a wallet, and you'll just have to, if you want to build an app, you'll just kind of have to flip the protocol around. So back real quickly, what we're going to need is WebLN, and we will get that with the Albi extension. So if you go to getalbi.com, then you can add this browser extension, which I've already done. And what we're going to need to do is connect a new wallet. So if you have the browser extension here, you can say connect a wallet. And if you already have an Albi account, that's cool. You can use their custodial setup. Or what we're going to use is bring your own wallet. So with this, we're going to connect. You can choose, if you already are running a node, you could connect via your node. They also support connecting with Nostr Wallet Connect. But we are going to use LNbits. So when we click on LNbits, it already fills in this URL. If you're hosting your own LNbits, you could fill that in. But what we're going to need is the LNbits admin key. So we'll just go to legend.lnbits. You may need to sign in. So I already have a wallet here with almost 420 sats. And over on the right, you'll see API keys here, and what it asked for was our admin key. So here we're just connecting our LNbits wallet to Albi. All right, cool, we have those 419 sats. So now in my Albi, I actually have already had an LNbits wallet, but this one is called LNbits 1. All right, so that's step one. What does that give us? Well, that gives us WebLN in our browser. You can find some more documentation on WebLN at webln.dev, but what we're going to be making use of is these few methods. So you can start to see there's this cool trick. If you open up your console, we have the window object, which exists in your browser always, but we have WebLN now. We should have WebLN. All right, we don't have WebLN for some reason in here. Let's see. Why don't we have WebLN in there? We have WebBTC. Well, I know that it should be in my Nostrudel. here we have window.webln. So we can see what's in here. We have these prototype methods with the list of all the methods that come with WebLN, and so that's going to be enabled by our Albi browser extension. So you can see we have get balance, and we have send payment here, and so that's what we're going to need mostly for this wallet. Alright, so to get started, we will need to clone this repo. This is in a finished state here, but we're going to check out this unfinished branch. Actually, this is the wrong. We need to go to Plebdevs. So if you're following along with these slides, this is, let's see, let's find this. It's on our Plebdevs GitHub, and you can see the Nostr Wallet Connect Wallet Workshop. And I haven't pushed up the branch yet, which was a mistake. We will do that real quick. So we have in here we are on this unfinished branch. So I'm going to push that up for you guys. And we should see now we have an unfinished branch. So if you clone this repo down on the pleb-devs GitHub account and at the repositories at NWC-wallet-workshop, then you should get it. So I'm just going to clone this. And for this, you're going to need Node.js installed. You can find that at nodejs.org. But once you have Node.js installed, you should be able to go into the wallet and run npm install. So this workshop is going to be sort of building off of another tutorial that I did, which you can find on the Plebdevs YouTube channel. And here we go over setting up a Nostr template using NDK in Next.js. So if you go along with this tutorial, you'll see how to start a new Next.js app and start using NDK within that app. And it'll explain more on what NDK is. So now that everything is installed, let's open this up in our code editor. I'm using Visual Studio Code, but you can use any code editor that you'd like. And let's just go through what we have here. So in that tutorial that I was just mentioning, we built this use NDK hook. And this is providing NDK. NDK is a library that makes building Nostr apps efficient and quite simple. So what this is doing is we're creating this NDK provider, and within it we're creating a new global instance of NDK. If you look at the NDK docs, you'll see that they recommend creating a single instance of NDK so that it can manage all your connections to relays and so on. So what we do here is we say that NDK is going to be equal to a new NDK instance, and we're passing in relays, which I have defined here in our .env file. So you can change this list of relays however you want. And this hook gets provided to our entire app within here. So you can see here that we're taking those relays from our environment file, and we are passing them to NDK provider. And what this is going to do is when our app starts up, it's going to create this NDK provider with that instance of NDK in it, and now we'll have access to everything that we build in this hook on the rest of our app. So what we have in here is this context value. This context value, again, gets passed to this provider. So this is what's being provided to our app. And we are also returning this useNDK hook, which is using our NDK context. So in our components, we're going to be able to use this hook, and it's going to return these values. So right now, what we need to do, actually, we are on the finished product, but if we get checkout unfinished, this is going to be where we're going to start with this workshop, because it has stuff to fill in before it fully works. So you can see on the unfinished product, we're just setting our private key and public key to empty strings. So what we're going to need to do is have a key pair for our wallet, because remember, the wallet needs to give its apps public keys of the wallet, and the wallet itself needs to have its own private key. So back in our slideshow, you can see here we are going to initialize a new key pair. So first we need to import everything. I'm going to copy and paste all of this into our hook, and then we can go through it. So there's all our imports. You can see most of these are from libraries. We're using the Nostr tools library for generating our key pair. Here I have in our utilities a function that takes hex and turns it into a byte array. And then what we're going to need to do is put this within our context provider. This is going to be useState is a thing in React that just helps you manage the state of your components, of certain variables within your components. So you can see here we're saying we want a private key and a public key. And this useEffects run, if they don't have a dependency array, they run just once when the app loads. And within this useEffect, we are checking local storage to see if we've already generated a private key and if it exists in local storage. So if it exists, we are just going to call this setter function to set our stored private key to that string, and we are going to we're going to derive the public key from this private key using this getPublicKey function from Nostr tools. So this will either set these variables to what we have stored, or if you're just starting the app up, it will create new key pairs. So it'll use the generateSecretKey function from Nostr tools, and it'll log it, which you probably shouldn't do. But for this example, it's nice to see that we've successfully created a new private key. And then again, we're just going to do the same thing. We're going to set the variables that we defined above to this new key pair, and then we're going to store our private key in local storage so that next time we load up, we have the same identity. Finally, we just need to give this key pair to NDK so that NDK can sign for us. So what this is doing, notice this useEffect here doesn't have an array down here, but this one does. So this is saying that if the private key ever changes, run this function again. So when the app first loads up, this is going to try and run, but private key is not going to be set, so it's just going to return. But this will also run, and it will set the private key, and then that will cause this useEffect to run again. And what we're doing here is we're using this class NDK private key signer, and we're just passing our private key into it. And so this just provides the information that NDK needs to be able to sign. So down here, we're using our NDK instance and setting the signer to this signer we just created using our wallet's private key. So now we're going to be all set up to sign events using NDK. You can see if we start this app up with npm run dev, and if you go, it'll show you down here that it started at localhost 3000. So if we go over to localhost 3000, which is where the local instance of our app will be running, you can see we have this wallet here. And if we clear our local storage and then refresh the page, you'll see it logged our new private key. And if you go to this application tab and then to local storage down here for the app, you can see now we have this private key stored. So now our wallet has an identity on Nostr. Also, you can see in the console here, it's logging NDK connected. So that's something that I covered in the Next.js Nostr template tutorial. But just briefly, that's happening here. So we're creating this new instance of NDK, and then when the app loads, we connect to it and log that NDK was successfully connected. All right, so finally, we still have these empty strings here. So we can use this syntax here, which will basically just say that we want the key of this object to be private key and its value to be whatever that value of this variable is. So we're returning from useNDK, we're returning this key pair. And you can see that if you go into pages and then our index page, you can see down here we're using this useNDK hook and we're importing that key pair. So now within the main page of our app, we have access to the key pair that NDK is using. And then you can also see down here, this is where the UI is built out. It's very, very simple. We have this input here and this input here. Those are these two things. So we're setting the option to add a budget and the option for an expiry. Those aren't going to be implemented in the wallet that we're building today, but this is a good feature to add to wallets because it allows your users to authorize limited spending from their wallet. So going back to the slideshow, what's next? We've generated a key pair, and here we're just making sure that the type of our NDK context is set correctly and that we are returning the private and public key we just created. And so now we're going to need to actually be able to generate this new NWC URI. So what we want to happen is we want to be able to click this button, and right now it doesn't do anything, but we want to create a new connection URI so that you can start putting that into apps. So if we go over now to this use NWC hook, this is where everything that's specific to Nostr Wallet Connect is going to happen. And you can see also within what we've already scratched out a little bit here is we are using this hook. And this hook needs access to our instance of NDK coming from the useNDK hook, and it also needs our key pair. So then in here, this is where useNDK is created, and you can see these are all the variables that we want to pass to it. And so in this workshop, I'm using TypeScript because I think it works really nicely with NDK, and also for implementing a protocol like this, it's helpful to define exactly what you're expecting so that you make sure that you stay on track with what the protocol actually is. So you can see here we're kind of defining some things. These all come from NIP47. These should look familiar to you. We're saying these are all the error codes that we could possibly use. There's more that's a challenge for you to do, to add in these other error codes. We're also defining what possible NWC methods. So this enum here is something from TypeScript, which is just basically saying like NWC methods can only be of these string values, and you can access them using NWC methods.payInvoice, for example. And then here we're defining some types. So again, this is from TypeScript. So we're saying that this is what we want the result to look like when we pay an invoice, or there's the getInfo method, and this is what we want the result to look like. And here we're using the union to say that the general NWC result can be of either of these, and you should implement the rest of the result types. And then here is what the entire response content will look like. So we'll get into building the responses, but the result type should be of type NWC methods. The result itself should be an NWC result, and this should be code, should be NWC error, or should be error codes. So you can see in here we have some errors. Like for example, this is a TypeScript error saying, we have this colon here, and so this is our definition of our function, and we're saying that we want this function to return a string, but right now it returns nothing. So getting back to generating the NWC URI, that's in here, and if we paste this in, we should see this linting error disappears, because now we're actually returning a string. What this function is doing is it's creating a new connection for our app. So it's generating a new secret key, which is going to be the private key of this connection, and then it's taking all the information we already have and assembling it into this URI, which is familiar from the slideshow earlier. We have Nostr Wallet Connect, our wallet's public key. So again, this is coming from the public key that we get from useNDK. And finally, what we're doing is storing this data to local storage. And this is going to be important so that later we can check to make sure requests to our wallet were actually authorized. So now that we're returning this URI, within our index file, you can see when you click generate URI, this event handler here on click, when you click that button, it'll call this handle generate URI function, which simply calls our generate NWC URI function from our hook and passes it the budget and expiry that we set, and then it sets the URI within this use state. So this URI here is just going to be displayed down here. So if we click the button, it should generate a URI for us. Alright, so now we have our new URI, and if you go to your local storage again, you will see, one sec, I'm going to change this to be down here. You'll see in local storage that you should have a new connection, and we didn't set a budget or an expiry, so this is the connection's public key, and then this is any data like expiry and budget, which we left empty. So now that we've generated our new NWC URI, we can take it and put it into a app. Oh yeah, I forgot. You can click it and copy it. So for this, we're going to use Nostr. If you go to nostrudel.ninja, this is a Nostr client, and you can, hold on, my battery is running low. I will be right back and plug it in so we don't die. All right, we're back. So if you go to nostrudel.ninja, here you'll be able to sign in, and you're gonna want to make sure that you're signed in with the same account. If you're using Alby will create a Nostr key pair for you, and this shouldn't be the case, but just because of the way that we're building this wallet, you're gonna want to make sure that the app that the wallet and key pair for Nostr that you're using is the same on your wallet and Nostrudel. So you can see here, if we go into our wallet settings, we have a Nostr public key. So if we just add an account and sign in with extension, Alby will say, are you sure you want Nostrudel to sign in as you? And now we're signed in with that key pair. What you can do on Nostrudel is in the settings and lightning section, you can use Bitcoin Connect here to connect with Nostr Wallet Connect. If we paste this in, this is copied from our wallet. We paste that in and nothing really is gonna happen here. If we go over, still nothing is happening because we haven't set up our subscription to the relay for Nostr Wallet Connect requests. So if you're in Nostrudel, you can see in the network tab, if we make it send this request again, it should send the request every time we open this, but maybe not. Anyways, we'll show that in a second. You should see WebSocket requests going out here. So what we need to do is make it so that the requests sent by Nostrudel can be picked up by our wallet. And so again, we're building a wallet here. This is not going to be an app. So what we're doing here is filtering for requests, but all that you would have to do to integrate Nostr Wallet Connect into an app is sort of just flip the event kinds. So we're gonna add in this use effect, and what this is gonna do is it's just gonna return if public key isn't set, but again down here we have this dependency array, so as soon as NDK sets the public key for us, this will run again, and this is gonna create a new filter. So here we're filtering for kind 23194, which are Nostr Wallet Connect requests. So if you were building an app here, then you would just change this to 23195, and you would filter for p tags of your Nostr Wallet connections. And then we just set this since filter here so that it will only look for events after the page loads. So this prevents it from pulling in events that were prior to the page loading up. And finally, it's going to call subscribe and handle. This is something we went over again in the Next.js template tutorial. But what it does is it takes our filter and it takes a handler function. Here we have handle NWC request. So let's just really quickly, we're going to implement this more. But we have it sketched out here. So let's just add in here a console log so we can see the requests that we're handling. And again, we're exporting this from this hook, and then it gets imported here from use NDK, or the handle NWC request gets imported from use NWC. So what this is going to do is this is going to send a request to the relays and say, hey, we want events of kind 23194 that are tagged with our public key. And then it's just gonna, down here, it's going to log that event that came in. And you'll notice here we have this option, close on end of stream event. We set that to false. Relays, once they run out of events, so we send this filter, and then the relay sends us everything that they have. And once they send everything, they'll say this is the end of this stream. You could set this to true, and as soon as that end of stream event is received, then the subscription will close. But we want this subscription to always be open, so we're setting close on end of stream to false so that it doesn't close the connection. All right, so if this works, what should happen is now in our console here, you can see we're subscribing to this filter. And now let's see if anything happens when we load this. Let's what we want is Nostr should be sending us a request, and here you can see it logs it. So here it's logging the full NDK event. We should have done the raw event, but you can see some information here like the event ID. Again, this is a kind 23194 because remember that's what we subscribed to. It's got tags, so this is our wallet's public key. So we are able to subscribe to requests and pick them up in our wallet. We need to actually do something with them now because right now Nostr can't zap or anything like that. So next, we're going to finish implementing our handle NWC request function. Back in use NWC, we're just going to fill this in. So again, this just takes an event of kind NDK event, which comes in from our subscription. And we are going to need to decrypt the event content. Remember, the requests, the content of those requests, the content that's saying this is what the app wants is encrypted. So we're going to need to be able to decrypt that data. So that's going to happen again in our use NWC hook, and we should have a decrypt NWC request. So again, this is TypeScript here saying that we wanted this function to return a promise because it's asynchronous, and it should return a method and params. This is the data that we are trying to decrypt. And it doesn't like it because we're returning nothing right now. But if we put this in here, that TypeScript error will go away. And you can see what we're doing here is we're using nip04.decrypt. nip04 is just coming from Nostr tools. This function, I'm just going to close these, they're not in the way. This function accepts a private key and a public key. These have to be from different key pairs. Remember, we're doing the Diffie-Hellman key exchange here. So this is our private key that we generated already. And then this is the app's public key. Where does that app public key come from? Well, in our request handler, you can see we're taking in an event, calling our decrypt function with the event's public key. So the app is going to be signing this request event with the private key in that Nostr Wallet Connect URI, and because it's signed by that private key, the event will have this pub key property that's the app's public key, and we're also getting the content from the event. So when we pass that to decrypt NWC request, we now have the app's public key and that content that is currently encrypted. And then this is our wallet's private key. And then finally, once it's decrypted, it's going to be a string, so we need to parse it into JSON, and then it should have these two properties. It should have a method and params. So now that we have this, you can see here we're logging the decrypted content. So let's try this again. If we go to Nostr, this just by opening and closing this, it should be sending another request. And you can see here we're logging now the decrypted content. All that it has in it is a method, and we're just logging those down here. So we're saying, this is saying that Nostr is trying to get this wallet's balance. All right, so now we want to actually respond to it, because right now we're just kind of ignoring it. We're saying, hey, look, we decrypted it, but now we need to actually go and respond to it. There's a lot of code here. This is all part of one function. I just broke it up into these two blocks. So this is going to be in send NWC response, which is defined here. So we'll paste that first part in, and then here we have the second part. It's got these dots here, which we should get rid of. All right, so how does this send NWC response function work? I guess we should go back to our request handler, which we didn't quite finish covering. So back in our request handler, remember, this is what happens whenever an NWC request comes into our wallet through our subscription. First, we're decrypting it, and that function is returning the method and the parameters, and this is where we logged those. Then we're calling validate connection. So this is, I just briefly defined here, but you should add some more validation if you want to build it out in a secure way. But what this will basically do, remember when we created that Nostr wallet connection, we stored it in local storage by the app's public key. So we're just looking for that. If it exists in local storage, then we'll say it was valid, we issued this connection. But if it's not found, we're going to throw one of these NWC errors. And the error code is going to be unauthorized, because we're saying this app is unauthorized to make this request. So this NWC error is just a class here that extends the basic error class. And we're just saying that this class is going to have an error code of type error codes and then an optional message. So what this gets us is every time we throw this NWC error, it's going to be within our request handler. So everything that throws an NWC error will be within this try catch block. So try catch is like, okay, we're going to try to execute this code, but instead of just breaking and throwing an error, we are going to catch it down here. And we're catching error and defining the error as E. And what this is saying is if the error is an instance of NWC error, remember that's the error class we defined above, then we're going to send an NWC response, because we want to let the client know whatever error happened. If it's an unknown error, we probably won't do anything. We'll just say that there was an error. We'll log that in our wallet. But that's on the app for making an invalid request. So back to send NWC response, if we throw any errors in here, we are going to call send NWC response. And you'll see here, we're looking for handlers. So we have these request handlers defined here, which is a map where the key of this map is going to be NWC methods. So this is just an efficient way to, based on the method of the request, we can get a handler, and we don't have to write a bunch of different code. We can just get the handler and execute it. But if that handler doesn't exist, in this case, we don't have anything. We just have an empty array. If that handler doesn't exist, it's going to throw another NWC error. This error is not implemented, so we're saying you're trying to make a request, it looks valid, but we haven't implemented it yet. So that's what's going to happen now, because we don't have, remember, we don't have any handlers here. So back in Nostr, if we get it to send the request again, then see, now we're sending a response. This gets logged in our send NWC response, but it has an error. It has the error code of not implemented. So now that we know we're sending responses, a little bit more on this send NWC response function. We're constructing the content, and again, this content, this just makes sure that we're doing everything correctly with the protocol. So we're saying that this content needs to be of type NWC response content, and That's just, it needs a result type and an optional error or error code. These question marks here mean it's optional. So we're saying it definitely has a result type, that's required. And then this send NWC response function takes these two optional parameters. So if result exists, we're going to set the result on there. And if the error exists, then we're going to set that error value. So then we have this content. We encrypt it. So now we're doing the inverse of decryption. We're using nip04.encrypt with, again, our private key and the app's public key. And we're stringifying the content to encrypt. We take this encrypted content and stick it within our response event. So NDK has a nice constructor here to construct new NDK events. And we're passing in our instance of NDK. So this is our global instance already connected to relays. Because this is a response, we're saying kind 23195. And remember, these are the tags that we need. We need an E tag and we need a P tag. This E tag is going to be the request events ID. So this function is also taking in the request event, and we're able to extract the ID, and then we're also able to extract the app's public key and correctly set the tags here. And then we're just setting the content to encrypted content. So that's where this should, says sending response, but maybe that's as far as it got. So next, what do we need to do? We have now added the ability to send responses, but now let's try and actually process these requests, because right now we're still not actually processing the requests. So here we're defining our request handlers. Again, this is a efficient way of defining all the possible handlers in one place. So now you can see we've kind of filled in this array. We're saying the key of this, we're gonna be able to find this by whatever method it is, and then we need to define the functions that will actually get returned. So that's all here. We have get balance and get info. We will just put those in here. So maps are a little bit confusing here. This is basically just an object. We'll see how it's used in a second, but this object you can find the values by their keys, which are here. So now what happens down here when we say request handlers.get, we're looking at this map and trying to get a entry in here that has a key that matches the method. And because we are using TypeScript, we can see here that the return type of method is going to be of NWC methods. And here we're saying the keys are NWC methods. So again, we are getting the function that we want to call dynamically through this map. But if that connection doesn't exist, that's where we throw this not implemented error. But now that we've implemented these two things and Nostr is sending us a get balance request, we should see it should send a result instead of an error. I guess briefly what get balance is doing is it's using window.webln. So we went over WebLN. That should be accessible now that you have the Albi browser extension. And it's just calling this webln.getBalance function. And then it's returning it. And so the handler is supposed to return the result type. And so you can see here, what we're doing is we await it because they're all asynchronous. We call it with whatever parameters came in from our request. And once this execution completes, that's where we call .then and pass the result returned to our send NWC response function. So once our handler executes, it'll either throw an error and that'll get picked up by this catch block, or it'll send an NWC response with the result. So let's see what that looks like. In here, we'll just refresh to make sure everything's good. And in Nostrudel, make Nostrudel send the request again. And now you can see we're getting this request from our Albi browser extension. This is because you can see it's coming from localhost 3000. That's where the request is being made from, and it's trying to get our balance. So this is just Albi saying, like, are you sure you want this app to know your balance? So we'll confirm that. It's going to send this response this time. It doesn't have an error. It has a result type of get balance, and it has the balance. This balance of 419 is what we see in our LN Bits wallet. Let's see if this works. We also should have, just like we had in Nostrudel, but for some reason we didn't have it other places. Now we should have this window.webln, and all of the webln functions are asynchronous, so if we call it like this, we will get a promise. But if we call it asynchronously with await, it's again making the request, and you can see we're getting the balance. So this is what we send back to Nostrudel. For some reason, I'm not sure exactly what Bitcoin Connect wants to get out of this loading state, but doesn't seem to. We are sending the response, and I don't see any other requests. So if you can figure this out, that's another challenge for you. But we should be connected at this point. Let's see. I want to see if it will send. Trying to show you within this network tab what happens when we do this. But it's not showing our network activity for some reason. Sometimes you'll see you can add these filters and filter by WebSocket type, and you should be able to see the WebSocket requests that are being sent here. But what Nostrudel is doing as an app, so we're building the wallet side, but Nostrudel is an example of an app that's implementing Nostr Wallet Connect. So what Nostrudel is doing is it's sending requests, and that's what our app is listening for here. And finally, it constructs this event response, and this is an unsigned event, but you can see we filled in the content with our encrypted content. We have our tags of E tag and P tag. All right, so this is getting signed. This is logging it before it's signed. But remember, we created in NDK and set our signer on there. And so what's happening in send NWC response, when we call .publish, this function, because response event, again, you can see here, is of type NDK event. And NDK events have a method called publish. This will throw an error if you don't have a private key set, but we already set that private key over in our use NDK hook. So this is gonna finish the event, add that created at field, add the ID, and then it's gonna sign it. All right, so now we're publishing events. We are responding to get balance. Sometimes apps will ask for info about the event. They mostly just want to know what your supported events are. So this is another benefit of using this request handler map, is right here we're using this request handler map to define everything that we support. And so with that, we are able to, we don't have to change this, update this array every time we add more methods. We can just get the keys, which again, the keys are going to be of these NWC methods. So this will create an array of all our supported methods. So now getting into the most exciting part of building this wallet is we get to pay an invoice. So we will copy this. We already have the pay invoice function defined here. And again, just reiterating, this is TypeScript here saying, you told me this function was going to return a promise of type pay invoice result, but you're not returning anything. You're just, this is called returning void. And briefly, what we're looking for here is we want it to return a pre-image. But you can't get the pre-image from an invoice until you pay it. So we're going to need to pay our invoice. We'll just copy the code from the slides into here. And again, we're using WebLN because it makes it easy for us to show this example of paying invoices. But really, if you were building a wallet like Mutiny Wallet supports Nostr Wallet Connect, they're running their own Lightning node, and that's where the payments are coming from. But this just makes it easy to show in the browser. We're using window.webln. Every time you want to call window.webln, you have to make sure that it's enabled. So we just do that in this function right here. We enable it, and then we can call send payment. So this function needs an invoice to pay, and that's going to come from our request handler down here. So remember, we extract the parameters of the request from the encrypted content, and then we're taking these encrypted parameters and we are calling our handler down here with those parameters. So depending on the function that you're calling, it'll take different parameters, but in general they all should. Each of these methods, in order to execute them, needs some parameters, or in the case of get balance and get info, these don't take anything. But so yeah, we're getting the params from the decrypted content and passing those to our handler. And in this case, because we're trying to pay an invoice, the parameters are going to be an invoice. So we're just doing a little bit of validation here, because we're passing in the parameters kind of blindly. We try to get the invoice, and we're just saying here, if the invoice doesn't exist, we're going to throw an error. It's not really clear. The client probably made a bad request, so we're just going to throw an other error code. All right, so now we know, because we're checking here, we have an invoice. We're going to enable WebLN, and this should actually be like WebLN sends like a payment result, and then I guess what does it return here? I guess it does just return. Well, let's find out. This was working before, so we'll say that the pre-image of this is the result of calling send payment. So once we send this payment, Alby will ask us if we're sure we want to send it, and then we'll get the pre-image and return that and send the NWC response. So again, once this, if any errors occur, it'll throw this internal error code, because there's nothing specific to Nostr Wallet Connect here, but something went wrong when we were trying to pay the invoice. So we say that it was an internal error, and we could optionally add a message like error paying invoice. All right, so yeah, so this function gets called down here in our request handler, and once the function completes, it passes the result, which in this case will be a pre-image, to send NWC response. So now we should be set up to actually pay invoices. We already connected, we already pasted in our NWC URI to Nostr, and we can go over here to check out some, let's check this out. See, this is what I wanted to show you. These are the WebSocket events that are being sent. So this is it fetching events. The client sending requests. See, it got an end of stream event. So anyways, we should have seen that when it was sending the NWC requests. But so now we're in Nostr. We are connected to our wallet in our browser over here, and we can start zapping. This is the power of Nostr Wallet Connect. We're already connected, and we can just zap. Let's give Jimmy 50 sats is too many. 15 sats. And so this, you can see this request is coming from Nostr. It wants to sign a zap request. We'll confirm that. And we actually haven't implemented it yet. So again, see, this is throwing this not implemented error. So we did implement pay invoice, but we didn't add it to our request handlers here. So just kind of reiterating, because maps are a little confusing. when we tried to get it by the method, it didn't exist, so we threw that not implemented error. So all we need to do here, every time we add a new method, is we just need to add it to this map here. So we're saying that this is the pay invoice method, and we want to call our pay invoice function. So this time it should work. If we go to Nostr, we'll pay him again. So here right away we got this payment request. We can see, if we look at our console here, we decrypted the content, and that content had a method of pay invoice, so that's how we were able to get our pay invoice handler, and the params were the invoice. So now that got passed to our pay invoice function, and then WebLN is telling Alby, hey, we want to pay this. So we will approve it, and it failed. Invoice was expired, so we took too long. Let's try again. Pay. Let's just refresh everything. That usually fixes things. All right, so we have events. We will zap one. We'll send him 50 sats. He's doing good work. All right, so now again we get this payment request from here, trying to pay another invoice. We will pay it. It may be slow because we're trying to tell our LNbits wallet that we connected to pay it. It'll take a minute. It's successfully paid. We can see from LNbits that we paid 50 sats. And here we sent this response with a result type of pay invoice, and we published the event. So if we go back to Nostr and do it again, you'll see the payment request is spinning, but then once we approve it here and pay it, once it's paid, our wallet's going to send the response back, and it'll get picked up by Nostr. Just waiting for LNbits to process this payment. It's taking a long time here. Oh, it might be because we have 2 pending payments. Let's see. If we close this, we might see an error. See, the WebLN threw an error, and then we created this error message of code internal, and this message that we added of error paying invoice. Let's see if we can try it again. See if it'll work. Let's zap someone else. Zap Jack. 50 sats. Confirm. Our LNbits will say, you sure you want to confirm? And LNbits is being slow here, but I think you get the idea. Alright, we won't wait for that. But again, we're waiting here for the invoice to be paid. And once it gets paid, we will send that response that we already saw earlier. So that's pretty much it on building a Nostr Wallet Connect wallet. If you wanted to build an app, again, you would probably have something similar to this. Because the responses and the requests both have a field that is of type NWC methods, you'd probably want to do something similar to this, where you have a map of request handlers, and instead of handling NWC requests, you'd want to handle NWC responses, and instead of sending NWC responses, you'd want to send NWC requests. Yeah, see, this is LNbits saying it was a failure, a temporary channel failure. So this is LNbits' fault. But that's okay. If you set it up with a node that could pay Jimmy Song, then you'd be good to go. But yeah, so if you're building an app, you will send requests. And the other thing that will be different is in your subscription, you're going to be sending requests to the relays, but you want to subscribe to responses. So again, you're just going to change this filter to instead filter for kinds of 23194. And you're probably going to want to do this. You're going to want to create the subscription before you send the request, because NWC requests and responses are what are called ephemeral events. So they don't exist on the relay for that long. So you'll want to subscribe, keep that subscription open, and then send the request and expect a response back from the wallet. Let's see. Is there anything else in our slides? I think that is all on building a Nostr Wallet Connect wallet. Here's a list of resources. Again, nwc.dev has a list of resources you can use for digging deeper into Nostr Wallet Connect. We have the NIPS repo here, Nostr tools. We have Alby's NWC SDK, so that would be worth going over real quick. If you go to github.com/getalby/JSSDK, you will get here, and here it makes a lot of the things that you have to do to build an app, they take care of it for you. So here's using some WebLN stuff, but here they have documentation on Nostr Wallet Connect. So if you don't want to build all those request handlers and everything, you can just use Alby. Alby's, you're not actually using Alby's browser extension here, you're just using a library that they have. And it makes it pretty simple. If you're an app, you're going to need a Nostr Wallet connection. And so they have this load NWC URL function, which is just kind of a placeholder for however you load in that Nostr Wallet Connect URL. And here we're creating a new NWC instance. So if you're not familiar with classes in JavaScript, this is what we saw when we were creating a new NDK instance. We say new and then the class and whatever parameters it takes. So in this case, we're creating a new NWC instance with that NWC URL. And then we're just enabling it. And what this is doing in this SDK in the background is it's connecting to our relays. So we didn't have to do something like that. We did have to enable WebLN, but this is important to tell the SDK that, okay, we're ready to connect to relays. And then all you'll have to do is call this send payment function, which makes it quite simple. Like really, this is all you need if you're building an app to implement Nostr Wallet Connect. But by implementing it yourself, you get a little bit more flexibility. Yeah, that is it for Nostr Wallet Connect. I'll just point you to our website, plebdevs.com, where you can see courses. So in these courses, in the front end course, you'll go more into how to actually build out your front end. For building this wallet, it's very simple, but you can learn there how to spice it up a little bit. We also have a list of our workshops and a link to our YouTube to see all of our videos. And you can join our Discord. I think that's the best place to go if you want help or just trying to get involved. If this is your first experience with writing code, the Plebdevs community is a great place for you. All right, that is all on building a Nostr Wallet Connect wallet.